Hello, I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at Level. So in this video, we are going to start our discussion and talk about SQL constraints. So now what we are doing is we are actually taking a dive deeper into the concept of SQL queries, okay? And very specifically talking about the queries that we have discussed already before, okay? So we have discussed all kind of queries. We have discussed DCL, we have discussed TQL, right? We have discussed DML, TCL, right? All the almost possible kind of queries that we can have. So now what we're going to do right now is we are going to talk about SQL constraints. Okay, what are SQL constraints, right? And how can you apply SQL constraints? So first, let's go through the definition. So SQL constraints are nothing but rules, okay, that we basically use to try to limit the type of data that can go inside a table, okay, and to maintain the accuracy and the integrity of the data inside the table. Now, when we talk about constraints, constraints can actually be divided into two types, okay? So we have like column level constraints and then we also have table level constraints, okay? Remember, constraints as a word means a set of rules, okay? So whenever you are adding something into a particular row or a particular column, you have to make sure that you follow those particular set of rules so that you maintain the integrity of the data that is basically stored inside the table. So constraints are basically, used to make sure that the integrity of the data is maintained in the database. So if you are in a scenario where, you want to make sure that no user is able to, I would say add wrong values to the database, you have to make sure that whenever you define the schema of the table, right, or you modify the schema of the table, you ensure that those constraints have been defined so that even if a user tries to enter the wrong details, they would not be able to do that. So now what we're going to do is we're going to take a look at all the constraints one by one and talk about them in detail about what they really do. Okay, so these are the constraints that can be applied to a table. So we have not null, we have unique, we have primary key, we have foreign key, we have check, and we have default. Okay, so these basically forms the set of constraints that we basically have available. Okay, so now would be a good time to actually go ahead and start the discussion on all of them one by one. Okay, perfect. So first, let's talk about over here, not null. Okay, so whenever we talk about not null over here, it is basically means that whenever we are going to add something to a column, right, its value cannot be null. Okay, so basically it restricts a column from having null value. Okay, and there are scenarios. For example, you have a table in which you are storing a student ID, student name, and student age. So in that scenario, you never want the student ID to be null, right? Because student ID is something that we are actually using to uniquely identify a student, right? Uniquely identify a row. And if that column itself is null, that means we are going to have problems and we are not able to maintain the integrity of the database. So we basically add not null constraint, okay, on a particular column to make sure that we do not have null values in that column. Okay. Remember, when you try to define the schema of the table, then also you can introduce the null constraint that the value should not be null, or you can also do that once you have defined the table, after that you can also define the constraint that you want to alter, right, the table, you want to modify a particular column, right, and you want to add more constraints in that column. Okay, so that's what basically the overall idea is over here. Now let's take a look by actually running a query itself and see how it works. Okay, so currently I will see what tables we have. So I'll drop the table student and make it again to show you how it works. So let's say I will do create table student, okay, and let's say here is the student ID. And now the first you mention the name of the column, then you mention the data type of the column, and then you mention not null. As simple as that. It is very verbose and it helps you to know that what kind of values can you store. And let's say age is also int. And there you go, right? You basically have the table in which you have defined a constraint that this particular column, student ID, which is going to take integer values, cannot have a null value over here. Okay, so whenever, even if you will try to add a null value, it will basically throw you an error saying that null values are not allowed in this column. Okay, and again, I think we've discussed the right justification for that as well, because student ID is something that uniquely identifies a student. So we never want in any situation that value to be null. Okay. All right. So this was our first one, which was not null. Next, let's talk about unique. Okay. Now what happens is, think of this scenario. Let's say you are adding, let's take two examples. There are two situations for this, right? So the basic use case for unique is that it basically prevents two records. When we say record, it basically means two rows, right? From having identical value in a column. Okay, so the idea is, let's go back and take the same example of student table once again. So you have a student ID. Let's say you have name and you have age, and let's say you have phone number. Okay, now let's say someone did a mistake and there were already two students in the class, right? The person tried adding the student 3, but again with the roll number or the student ID 2, which is wrong, right? Student ID is one such column in which every ID should be unique, right? We cannot have identical values in two separate rows for a single column. Correct? And that is what this unique constraint helps us to define, that idea that in a certain column for two different rows, we cannot have two identical values. Okay, so one place is where we can apply it on student ID, and the second place is, let's say we can apply it on phone number as well, right? Neither do we want that, let's say if student 1 has a phone number, right, student 2 also has the phone number same, right? That is not valid. Two different students cannot have the similar phone number. So even phone number as a attribute, as a column, should also have unique values similar to student ID. But if you will see over here, the same rule doesn't apply on name, okay? Because two students can have the same name. So if I will apply this unique constraint over here, it will be wrong, right? Because name does not have to be unique. Similarly, if in a class there are a lot of students, there is a very high chance that all of them are going to be of same age, right? So again, we don't have to apply the unique constraint over here. Okay, and how do we actually implement this? Even that is very simple and very similar to how we created the student table. So here you create the table. Okay, when you define not null, similar to that, you can also define unique. Okay, and let's say, and you can do it for as many columns as you want. Let's say here you have phone number. I'm creating the student table again only to take, let's say, integer values, and again I want the values to be unique. So what it will do is, it will make sure that the values are indeed unique. Okay, and you can see over here, if you will run a query which is describe, right, it actually helps you to describe the table. So you will see over here that here we have the field, here we have the type over here, right, and here we have null kind of a constraint over here, right? And it says that in null, student ID for null mention knows. That means no, or null is not a valid, I would say, at value that you can put in the student ID column. So it very well puts over here as well. Okay, there is a concept which says keys and primary key. This we will come next, so leave it for now. But see that in the keys column for phone number, it says unique, right? That means the phone number should be unique for every student that we enter. Okay, so that's what pretty much the overall idea is. If you ever want to see if your changes regarding the SQL constraints actually get added in the databases or not, so what you can do is, or in the table or not, what you can do is you can run this describe query. This describe query actually shows you the entire schema of the table, and as well as it also shows you a few extra constraints that you have added on the data. So it's always good to see whether if you can verify the changes that you have done and are they actually working or not. Okay, so this would be our second one, which will be about unique. Okay, not null means that the null value is not allowed in a column. Unique means that the value in the entire column for the every row should be unique. Okay, the value should not be repeating. Next, what we have is primary key. So what happens in primary key? Okay, in primary key, we basically apply this constraint to uniquely identify each record. Right? If you've not watched the keys video, I would recommend watching that. Right? There you will get the entire idea what a primary key is and what is the purpose of a primary key. Right? So we have had detailed discussion over there already. I'll just give a quick overview over here that whenever we are using primary keys, a certain attribute, basically, if it is a primary key, it means that that particular attribute is going to be used to uniquely identify each and every record or every row, okay, or tuple. Record, row, tuple, or are similar things only. So whenever a column is primary key, it is used to uniquely identify. And as you can see again in the student example itself, that I can use the student ID very well to make it a primary key, right? Because student ID is enough to uniquely identify each and every student. Whenever you would have seen when you were in school, right, there used to be a lot of students in the class, and every student used to have a unique roll number assigned to them, right? Roll number 1, roll number 2, and it used to happen sometimes in an alphabetical order, right? And everyone used to have a unique roll number. Never did we use the name of a student to uniquely, because name are not unique, right? Names are not unique, but definitely student ID in an incremental manner can be kept unique for each and every student. Hence, student ID can become primary key. Okay, and name and age cannot be, because name and age can be repetitive. So primary key as a constraint basically helps to uniquely identify each record in a table. And whatever attribute you are considering as a primary key, it should always contain unique values. I'll write this down over here. Primary key attributes should contain unique values, right? And it cannot contain null values as well, which was pretty much the previous point that we discussed as well, that they cannot contain null values. Okay, now here what we will do is, and if you would have seen the videos for indexing also, you would have remembered that in the concept of primary indexing, we usually take the primary key of the table also to do the indexing concept. So primary key has a wide variety of use cases, and it's a very important concept to know as well. Okay, let's take an example here as well. Let's say maybe I drop the table and then I try creating the table again. So here what you have to do is, similar to the way you were defining other constraints, you can define this constraint as well. So you just simply have to write this and it will make a primary key, which is this. Okay, here you can see primary key as this, and automatically you can see that although I did not even define that it cannot take null value, but it is by default the case that if something is a primary key, right, it is not supposed to take null values. Okay, so this kind of constraints comes automatically, and although it doesn't show because key part is like mentioned over here, all student ID will have to be unique as well. Okay, so even that part needs to be followed. All right, so this is what I think the third constraint was, which was primary key. Again, constraint being some rules that we are defining on each and every column, or rather a table, to make sure that the integrity of the data is maintained. Okay. All right. Next, what we will do is we will talk about foreign key. Again, this topic in detail has been covered in the previous key videos, so you can refer those videos as well. The overall concept is that foreign key is used to relate two tables. Okay, now the relationship is that the primary key of one table is used as a foreign key in another table. So it says that the primary key of one table is used as a foreign key in another table. Okay, to actually give you a quick example on how this would work, let me give you an example. Let's say there is a customer table. Okay, in the customer table, I am storing the customer ID, I am storing the customer name, as well as I am storing the address. Okay, so here it is going to have some values, and this definitely is the primary key of this table as well. Okay, similar to that, we also have a order table. So what happens in the order table is that you have order ID, okay, and you have the order name, and you have the customer ID. So basically it means that, let's say here the customer name is this is Ajay, and some address is there. Order ID is 22, order name is, let's say, order 1, and the customer ID is 101. So this helps to know that the order ID is 22, the name of the order is this, and it is placed by the customer having the ID 101. So Ajay basically placed the order, right? So here customer ID is a primary key, right? And now customer ID as a primary key is used as also an attribute in for order table. So this becomes the foreign key as well. Okay, that is what pretty much the overall concept is. When the primary key of one table is used as in another table as well, we basically have foreign key explained. And how do you do that? So you simply can, I'll write it down here only because it's very simple. So you have create table. Okay, let's say you are creating the table order detail, right? And customer table already exists. So you'll do this. Order ID is int, and it is also going to be primary key, correct? And here you have order name, right, which can simply be a string, correct? And or let's say I am putting not null over here because I never want the order name to be null. And apart from that, there is another attribute, customer ID, which is of the type int, and this is a foreign key. So you write foreign key over here, but you also have to write the foreign key and the primary key of which table. So this is basically referencing, okay, basically referencing to the customer table, okay, and in that to customer ID. Okay, so this is what pretty much the concept is. Let's go through once again. So we do create table command, for creating the table. The customer table already exists. We are creating the order detail table. Order ID is again the primary key. Order name is a simple name of the order. We are keeping it not null. And then customer ID is basically the foreign key. So you first write the data type for that, right? Then you write the particular constraint foreign key. Then you have to write references. That means what table is it referencing to? Then you have to write the name of the table where it is a primary key, and then what name it is being used for in that column. So this is CID. Okay, so CID in the order table is basically made of foreign key, which is referencing to the CID column in the customer table. That is what the overall concept is regarding this. Now, the next one that we will talk about is the constraint, which is check. Okay, so let's see what the check basically does. So whenever you are trying to use check, right? Check basically is a constraint that works at column level. Okay, so what happens is the check query basically restricts, let's say if I apply it on student ID, the check query will basically restrict the student ID. Let's say in case we only want a certain range of values. Let me give you an example. Let's say here, constraint to be applied at column level. Okay, so if let's say I do something like this, in this, let's say first I drop this table and then I create a table. Okay, so now over here you can add a check, okay, where you want to make sure that always the student ID is greater than 0. Okay, and based on this check, what will happen is whenever you will try to add any student to a particular table, it will always have to check whether that particular value in the particular student ID column is greater than 0 or not. And if it is not, then it will basically give you the error that you are not following the prescribed constraints, the SQL constraints that are applied on that particular column. Okay, so that's what check basically is. And default, I think we have already talked about default, right? Default is basically when we want to have, let's say, a default value assigned to each and every attribute for that particular column. Okay, let's say initially when we are trying to assign, let's say we have created a column for age, right? And we want the default value for age to be 0. So what we can do is, for that we can apply the default constraint, right, wherein we can mention the default value to be null. Okay, and if the default value is null, basically what it will do is by default it will populate all the values on that to be 0 if it is age, right? Or you can probably add any, I would say, default value you want, but default basically does that. We've already talked about default constraint. Okay, if you remember when we tried to create tables, so there we have done a detailed discussion about what default is. Okay, so you can check it out as well. And this all basically forms the entire constraints, SQL constraints that we have available, which can either be applied on the table or they can be applied on the column. So when we talked about check and default, they are basically the constraints which are column level constraints, okay, which are applied on the column, and rest all are applied on the table. Okay, so I hope this is clear to everyone. Again, I would say the best way to learn is to take a few examples yourself and run a few queries to understand. You can create a table based on that attribute, then maybe drop that table and then create another attribute again. But this is how you basically have to understand this topic. So to quickly summarize what we did in this video is, we talked about SQL constraints. SQL constraints are certain set of rules and regulations that are applied either on the entire table or they are applied on a certain column to make sure that the data integrity is maintained in the database. Okay, and the constraints can be two types. I told you, you can have column level constraints or table level constraints. Column level constraints only try to define a limit or constraint on the column, and table level constraints try to define the constraints on the table in the entire table itself. Okay, So what all constraints did we talk about? The first one we talked about is not null. That means we do not want a certain value in a column to be null. Okay, so we basically put not null so that no value is null in that particular column. Then we have unique. Okay, unique is basically a constraint when we want to make sure that in a table, right, a certain column always have unique values inside it. Okay, that means, for example, if it's a student ID, each student should have a unique ID. If it's a phone number, every student should have a unique phone number. Okay. Next we have is primary key, where we want to basically ensure that a certain column can be used to uniquely identify each and every record in that table, and that column becomes the primary key. Again, the primary key values should be unique and they should not have any null values. Next is foreign key, where the primary key is used basically as a foreign key in another table. Okay, a primary key attribute is used in secondary or other table as well. And you just have to write foreign key, then you have to write references, then you have to write the table in which it's a primary key, and then you basically have to write the column value. Okay, and then we have check, wherein we basically want to add some additional check, wherein let's say we do not want any student of the age less than 18, or let's say we do not want any student, to have a student ID less than 0, or we do not want any phone number to be less than, let's say, 10 digits, right? So these are all the constraints that you basically add, or basically all the checks that you can add. And default is, let's say, for a certain value, by default you want a value in the table, right? Let's say default is some value that you want in the table by default to be present. So for that you can add the default attribute, wherein for a particular column all the values in the column will be default. Okay, let's say null, or let's say 0, anything you want. So this kind of completes our entire conversation about SQL constraints. So I hope now you will be able to practice a few examples on this, right? Create a sample table and try out all the examples and all the constraints that we have discussed. Now we'll meet in the next video where we will talk about SQL functions. Now SQL functions is again meaning going one level deeper into the entire concept of SQL queries and seeing what all and what more can be done on the data that is available to us. Okay, so thank you so much for taking a look at this video, and I will meet you in the next one. Bye.